All right, so let's move on to our last one, number 5. So when it comes to transformation of function. So for number 5, again, we're given the original function of x graph of absolute value of x, v-shaped, and they want us to obtain the graph of f of x 2 times the absolute value of x plus 3. Now, there's two different transformations here, right? Not only are we adding a 3, but we're also multiplying by a 2. So there's two different transformations happening here. So let's list them. Let's see what kind of transformations those are. So we have our original function of x, which is the absolute value of x. Then we have our transformation function, which is f of x equals 2 times the absolute value of x plus 3. Now, what's happening here? The plus 3 is on the outside. That tells us that we're moving up 3 units, right? We're moving up. Now, this 2 is being multiplied also on the outside, and it's greater than 0, so we're going to it's going to be a vertical stretch here. So it's going to get more narrow by 2 units. Okay, so there's two transformations happening here. The plus 3 that's on the outside of the absolute value, meaning it's only affecting, that means it's affecting the x-axis. We're moving up 3 units. Then we have the 2 being multiplied, and since 2 is greater than 0, greater than 1, we have a narrow stretch by 2 units, okay? If it was 1/2, it would get wider. So let's change it. Let's say we had f of x equal 1/2. Actually, let's try another one here. I'm going to clear the whole thing. So let's say let's do one more. Let's say our original graph is fx equal absolute value of x. Then we had f of x equal negative 1/2 times absolute value of x. Let's do something inside too, minus 3, right? And then let's put let's put a plus 3 inside and like a minus 3 on the outside. Here we have 4 different transformations. We have the minus 3 on the outside, the plus 3 on the inside, the 1/2 being multiplied, and the negative, okay? So let's start with this one. The minus 3 is on the outside. So here we're moving down 3 units. Then we have our plus 3 on the inside. So since it's in the inside, we're going to move left 3 units. And here, since we're multiplying by negative on the outside and a 1/2, we're going to reflect over the x-axis and get wider. Sorry, vertically wider. Okay, so here we have a couple different transformations. We have it's going down 3 units because of the minus 3 on the outside of the function. Then we have go left 3 units because of the plus 3 on the inside of the function. Then we have reflect over the x-axis since we're multiplying outside of the function by negative, and then it gets wider since our a is less than 0. It's between 0 and 1. Okay, so now let's go ahead and graph the question we were just doing before, right? Let's go ahead and graph this to see if our transformation was correct. So we have our original graph, which is f of x of absolute value of x. Then we have our 2 times the absolute value of x plus 3 on the outside. So let's see what happens to our graph. So the purple graph represents our first function of x, absolute value of x. The red graph represents a transformation. So it moved up 3 units because of that plus 3 on the outside. So 1, 2, 3 went up. All the points went up 3 units. 1, 2, they all went up 3 units. Then, not only did we move up 3 units, we got it got wide, also more wide. More narrow. So we went up to 3 units because of the plus 3 on the outside, and the graph got more narrow. It was vertically compressed. It got more narrow. It was vertically stretched. When you stretch something vertically, it gets more narrow. So we went up 3 units and it got more narrow because we multiplied by 2, and it's on the outside, which is greater than 0. Okay, now let's move on to piecewise functions. So here for number 6, we have a piecewise function. So what that means is you're going to be graphing pieces of a function. So here you can see that there's two things here, right? It's f of x equals 2x if x is less than or equal to 0, f of x equals x squared if x equals 0. So what this means is they want you to graph both of these functions, right, 2x and x squared, but they only want you to graph pieces of this function, right? So for example, for the function 2x, they only want you to graph this for the values of x that are equal to 0 or less. They only want you to graph x squared for the x values that are greater than 0. But before we graph piecewise functions, they want us to do something else. They want us to find the indicated function value. So for A, B, and C, they want us to find the indicated function value. So let's see what that means. So when we usually find indicated function values, we only have one function, right? So let's take a look at that. So usually, right, you see something like this, and then they ask you, like, let's say this, right? Find f of 1. And then what you would do is you would substitute 1 for x and you would simplify, right? This is what you would normally do, right? But now there's more rules, right? So let me just write it down. We have our piecewise function f of x equals 2x if x is less than or equal to 0, and then x squared if x is greater than 0, and then they want us to find the indicated function value of f at -5, okay? So what this means is, which function can I use to evaluate the value of f of -5? So let's take a look at the first function, 2 of x. Can I use 2 of x to evaluate f of -5? Let's see. I can only use this function, 2x, if x is less than or equal to 0. Is -5 less than or equal to 0? Yes, it is. So I would use that specific function. So I would use the 2x. So that's 2 times -5, and that's equal to -10. Okay, now they want us to do f of 0. Okay, so let's see which function this one applies to. Can I use 2x? Let's see. Is 0 less than or equal to 0? Yeah, it is. So I would have to use this function, 2 of x, to evaluate f of 0. Now let's try f of 3. Okay, I can only use 2 of x if my x value is less than or equal to 0. So is 3 less than or equal to 0? No. 3 is not less than 0, and 3 is not equal to 0. So I cannot use 2 of x to find the value of f of 3. Let's see if I can use x squared. I can only use x squared if my x is greater than 0. Perfect, because 3 is greater than 0. So I have to use x squared to evaluate the function of 3. And that is how it's done. So these are basically just specific rules for each function. I can only use 2 of x if my x value is less than or equal to 0. So for -5, I was able to use it, and for 0. For x squared, I can only use it if my x is greater than 0. So for f of 3, I had to use x squared since 3 is greater than 0. Let's take a look at another example. So for number 7, we have the same thing. We have functions. F of x equals -3, which I can only use if my x is less than -2. We have f of x equals x squared, which can only be used if my x is between -2 and 1 and equal to them. And then we have f of x equals 2x plus 3, which can only be used if my x is greater than 1. And then same thing, they want us to evaluate these functions. So let's go ahead and do that. Okay, so we have our piecewise function over here, which is -3, can only be used if x is less than -2. Then we have x squared, which can only be used if x is between -2 and equal to -2 and between 1 and equal to 1. And then we have 2x plus 3 if x is greater than 1. Okay, and then they want us to find f of -4. Okay, so which function can I use to evaluate f of -4? Let's see. Can I use the first function, f of x equals -3? Well, is -4 less than -2? Yeah, actually it is. -4 is less than -2. So I have to use the first function. So that equals -3 because there's nothing to plug in, right? It's just f of x equals -3. That means y equals -3, right? That's the function. F of x equals -3 is the same thing as y equals -3. It's just a y equals line, so it just equals -3. Now let's do the second one, f of -2. So is -2 less than -2? No, it's not less than -2. It's equal to -2, but so that means I can't use the first function. Let's see if I can use x squared. Is -2 between 1 and -2 or equal to them? Yeah, -2 is equal to -2, so I have to use x squared. So -2 squared is going to give me +4. Let's do the last one, f of 2. Okay, so f of 2. Okay, let's see which function I can use to evaluate this. So is 2 less than -2? No, so I can't use f of x equals -3. Is -2 between 1 and is 2 between 1 and -2? No, so I cannot use the function x squared. Is 2 greater than 1? Yeah, 2 is greater than 1, so I have to use this function, 2x plus 3. 2 times 2 plus 3, that's 4 plus 3, which is 7. And that is all for evaluating piecewise functions. Okay, so let's